Hello everyone, happy to see you here on my channel Relax and Math, and today we have a really interesting question. We need to find the area of this square which is inscribed into a triangle. And what do we know from here? We know that this side AB equal to 2, yeah, this BC equal to 3, and that's it. We don't know anything about this square, so right now I suggest you to pause the video and try to solve this challenge by yourself. Write your thoughts, write your suggestion, write your solution down into the comment section, and we will check our answers in the end of the video, so it will be really interesting. So right now let's start. First of all, let's start with very basic thing right here. If we call this side of this square as x, yeah, then each of these sides will be equal to x, because each of these sides is equal to each other right here. So we have x right here, and we have x right here on the top. And obviously we can look at this question in a perspective of angles. So if you're talking about squares, so this angle equal to 90 degrees, this one equal to 90 degrees, this one equal to 90 degrees, and this one equal to 90 degrees. This is a very obvious thing, so let's start with this. We have a square, this x, and we have a lot of right angles. So this is our first step. Second step right here, let's consider this triangle on the top, AOB, and this one, BDC, on the right side of this square. And I want to consider this angle, AOB. Obviously, this angle has the same 90 degrees because we are talking about a supplementary angles. So 90 degrees, 90, and of course this angle will be equal to 180, which is absolutely correct. So this one equal to 90 degrees. And with the same logic, we can easily write that this angle BDC is also equal to 90 degrees. Okay, because these are like supplementary angles. Really great. Right now let's consider these angles. Right now, really tricky moment. This angle will be the same as this one, because these are corresponding angles. And right now let's consider these two triangles. This one, AOB, on the top side right here. This triangle will be similar to this triangle on the bottom right side, okay? Because the corresponding angles are similar. We have two similar angles right here. So we're talking about two similar triangles. And right now let's find a coefficient of a similarity. We can easily do this. And how can we find this coefficient of a similarity? We know this hypotenuse equal to 2, and this hypotenuse of this bottom right triangle equal to 3. This is only one way how can we find this coefficient of a similarity. This is a ratio of our hypotenuses. We have 2 and we have 3. So coefficient of a similarity of these both triangles equal to 2/3. Right now we can easily find this leg right here, AO, and this one, DC. Okay, how can you do this? Obviously, if you're talking about coefficient of a similarity, then these corresponding sides will be similar to each other. So then this side will be equal to 2/3 times x, yeah, and this side will be equal to, right here we have 3/2 times x. Okay, 3/2 times x. Really great. So as you can see right here, we know this side. And right now, really tricky moment. Let's look closely at this big giant triangle A right here. Let's call, for example, as H. Yeah, we have right here AHC. What do we know from here? We know that this angle equal to 90 degrees. So we are talking about a right triangle. And obviously, we know the hypotenuse. A hypotenuse equal to 2 plus 3 equal to 5. And we can easily find both legs. This is, but with x, but doesn't matter, we can easily find this x from this equation because we're going to apply a Pythagorean theorem. So if we're talking about this whole side right here, so 2/3 x plus x, as a result we have 5/3, okay, so we have right here 5/3 times x. This is our AH. And in the same logic, HC we can easily find x plus 3/2 times x. As a result, we will have 5/2 times x. So we have plus 5/2 times x, which is equal to hypotenuse. 2 plus 3 equal to 5, but with one really interesting moment, we need to consider this as a square. Okay, so right here we have square, we need to raise this side to the second power, and we need to raise this side to the second power. Okay, really great. Now, how can you find this x from this equation? According to this question, we can easily divide both sides by 25. When we divide both sides by 25, because we will have 25 in our numerator, and right here 25 in our numerator, and right here 25. So when we divide both sides by 25, we will have the next thing. We will have x squared over 9, yeah, plus x squared over 4 equal to, right here we'll have 1 because we divide in both sides. So right here we divide in both sides by 25. Really great. And right now let's add all of this fraction right here. So as a result, our common denominator will be 36. As a result, right here we will have 4x squared, yeah, 4x squared plus 9x squared. okay, equal to 1. And from here, really easy solution, because we have like 13x square over 36 equal to 1. Okay, let's continue this right here, because we can easily find our x square from this question, because according to cross multiplying we can easily do this. So our x square equal to, right here what do we have, 36 divided by 13, 36 divided by 13. Really great. And we have like square units, I don't know exactly, centimeters, meters right here, square units right here. And obviously x squared, this is the area of our square. This is the area of our square. We have x times x, this is our area, and we don't need to find our x, because x squared, this is what we need to find from here. We have 36 divided by 13, and maybe someone interested in like approximately answer, so let's write our answer. Maybe someone interested in this. If you have a chance to find it in your calculator, for example, in your exam, yeah, the area equal to 2.7 square units. Okay, and this is 2.77, I guess, yeah, something like that. So 2.77, this is our area of our square, and obviously this is a solution to this challenge. I solved this challenge according to a coefficient of a similarity, according to a similar triangles, and you can also write your thoughts down into the comment section. Maybe you have another method, maybe you will find it according to a Pythagorean theorem right here. You can easily find AO from this triangle, you can easily find DC from this triangle, and maybe you can write an equation according to both Pythagorean theorems, according to this triangle and according to these triangles, something like that. You can easily solve this challenge according to this approach. It will be really interesting to read about it. This is my approach. Write your question, write your suggestion down into the comment section, and I hope you understand this explanation. I hope you learned something new. You can also write your ideas into the comment section. It will be really interesting to read about it. So thank you for your time. Have a great day.